Okay, we'll just take a look at a demo of latent heat of vaporization now. You see this water is getting heated and this is a thermometer. This is a digital thermometer rather. And you can see that as the water is getting heated, the temperature of the thermometer is rising. We have two kinds of units being used here. Um, Degrees Celsius as well as degree Fahrenheit. And as the water goes on heating, what happens is the temperature slowly rises, and you can see the steam coming up, and here you see it is almost at the verge of boiling. This is Fahrenheit 202, 203, 205, it is rising. This is degree Fahrenheit, and this is degree Celsius. It is rising to about 100 degree Celsius, and you'll see that just yes, water has started boiling now, and it is the temperature is now more or less not rising anymore. It is about stable at around 216, 217, 216, 17. It is around about stable. In Celsius also it is about stable uh, at about 103 or 104 degrees Celsius, because this may not be pure water. Pure water boils at 100 degrees Celsius at normal atmospheric pressure. Now this the flame of the burner has been reduced, but still you see when water is still boiling, its temperature is around 100 degrees Celsius. It is not rising so much. Okay, so this was a demo of actually how uh, this latent heat of vaporization works, and water while boiling actually its temperature does not rise, the reason we have seen earlier. Now the same thing happens in the case of ice also. Suppose we take some ice, okay, and we uh, heat that ice up. We are taking some ice over here, so some crystals of ice, and we are say inserting a thermometer into this ice, and we are supplying some heat. Okay, so say that this is a thermometer. We are not going to draw in details. So this is a thermometer, and we are going to now heat this. So when we heat it, the same thing, the same observation is seen again. What happens is, we are going to just write it down. What happens when this is heated? When this is heated, we find first, when it is heated, the temperature rises. Why does the temperature rise in the thermometer? The temperature rises because the particles in the solid receive energy due to supply of heat, and their energy increases, which is seen as rise in temperature in the thermometer. Okay, now if we go on heating further, what happens is, there comes a time when the particles in the solid state, they start getting converted into the liquid state. That is, the particles in the solid state which were only in to and fro motion for about their mean position, they now start getting freed from this mean position, and now they are able to move about throughout the volume of the liquid. So that happens at a fixed temperature, and that fixed temperature we call the melting point of the solid. So what happens is, as we go on supplying more and more heat, there comes a time when at a particular temperature the solid starts to melt, and at this temperature, when the solid starts to melt, we find that now the temperature in the thermometer does not rise till the solid has completely changed into liquid. Okay, the temperature does not rise till the solid has completely changed into liquid, and this happens although we are supplying heat. This means that this supply of heat, which is used to break the bonds between the particles in the solid state, are not seen as rise in temperature. Okay, so it is not seen as rise in temperature, and since this is not seen as rise in temperature, we call it latent heat, that is hidden heat, and this latent heat is called latent heat of fusion. So latent heat of fusion is experienced when solid changes into liquid, and latent heat of vaporization is experienced when liquid changes into gas. So that was about latent heat. We'll come back in a later video to try and understand some other properties of matter, and we will be soon completing this chapter. So we'll take a short break now.